Unit 2, Lesson 3. This is inverse functions. So we just go through that worksheet. I'm going to talk us through some of the tasks on it, give us an overview of how this works, and you guys are going to be expected to do some of it yourselves. So you should have the worksheet open in front of you, and we're going to look through some of the ideas on this. Okay, so I give you to talk about an inverse function. We talk about this idea of, okay, we look at a daily routine that we have. Now this is a silly example, but it should help you to understand the idea of an inverse function. So it talks about put on your socks, put on your shoes, tie your laces. And then in the evening, you do the reverse steps, but in the opposite order. So last you tied your laces, so that means that first at night time you untie them. Second last you put your shoes on, so that means you take them off. And then the last thing we do was the first thing is to undo the first thing that we did in the morning, so we take off our socks. Basically, an inverse function undoes the steps but in the reverse order. And if you see, the net result then is that we end up as we started, barefoot. We're going to apply that idea later on. So it's important to notice as well that if f of x is a function, we call its inverse like that, f to the power of -1, but we just say f inverse of x. All right? So let's get on to task 1 then. So we have f of x equals 3x minus 2 over 5. So let's describe what that function f does to its input x. Well, firstly, it multiplies it by 3, then it subtracts 2, and then it divides by 5. Now, so that means that if we want to create the inverse function, we have to do the opposite steps in reverse order. Okay, so last I divided by 5, so that means first I multiply by 5. Then I subtracted 2, so that means now I have to add 2. And then I multiplied by 3, so that means I have to divide by 3. So, what does the inverse function look like? It looks like this. F inverse of x equals 5x plus 2 divided by 3. Okay, so we did it by doing the opposite steps in the opposite order. Now, let's see how would we do that. It's all well and good doing it like that in your head, but when you come to a more complicated one, sometimes you're going to have to be able to do it more mathematically. So here's how you do it mathematically. So instead of f of x, I'm going to use y equals 3x minus 2 over 5. So what I'm going to do with that, I'm going to solve it for x. So I want to isolate x, and then I just switch the letters around. Okay? So I'm going to get 5y equals 3x minus 2. Move the 2 across. 5y plus 2 equals 3x. And then you divide by the 3. So x equals 5y plus 2 over 3. And that's it. And so instead of saying, so what I've done is I found the inverse function of f of x, so I'm going to say it's f inverse of x, and I just switch the letters, 5x plus 2 over 3. Okay, that's basically how task 1 works. Now, here's the deal with that. I'm going to continue down here, and I just want us to know what we've got. So what we've said is that f of x equals, 3x minus 2 over 5. And f dashed of x equals 5x plus 2 over 3. Now, here's the thing. They're inverse functions. That means I put something into x, right? So remember at the start, our first example, you start off with barefoot. By the time you finish the process first, the first routine, you got your shoes on, and then by the time you finish the second, you're right back barefoot. So what we're looking at here is that when I take x, I start with x, then I calculate what f of x is, and then I put that into the other function that reverses it, and it should take me right back to x. So what should happen is that when I do f of f inverse of x, it should take me right back to where I started, which was with x. So what you can do is you can verify that. You can verify that f inverse x and f of x are actually inverses by doing this. Look, so what I'm going to do is let's write that in black marker or black pen instead. So I'm going to do f of f inverse of x. So that is f of 5x plus 2 over 3. Now, so f of 5x plus 2 over 3. So that means in the function f, I'm going to take out any x's and replace them with 5x plus 2 over 3. So I'm going to have 3. This is where my x was. Minus 2 over 5. Now what goes in here? 5x plus 2 over 3. So let's see. So by simplifying that, look, the multiplication and division by 3 are going to cancel. So I'm going to be left with 5x plus 2 minus 2 over 5. Plus 2 minus 2 cancel, so it's 5x over 5, which leaves us with x. So when I did f inverse, or I did f of f inverse of x, it took me right back to x. I started where I finished, or I finished where I started. Okay? That's how that works. Now, there are some practice examples below, A, B, and C. All you have to do is find the inverse function like I showed you, and then do f of f inverse, so f of the inverse function, and check that it gives you back out x as your answer. Okay, so I'm going to get down to this really quickly. So we're talking about the graphs of inverse functions. So what's important is, okay, if you're given the graph of a function and you're asked to draw the graph of its inverse, firstly, here's what you have to know. I'm going to draw in this line here, dotted red line. That's the line y equals x. Okay, slope, it passes through the origin and has slope 1. Now, here's the thing about this. If I'm given the graph of a function and I want to draw the graph of its inverse, and IB asks this a lot. So if I say that that's f of x, and a question would be, draw f inverse of x. Well, what it is, it's a reflection through the line y equals x. What does that mean? Well, this is what it means. What you do is you pick a couple of points on the function that you're given, and you go across horizontally until you meet the line y equals x. And then whatever distance you've traveled across, you go that same exact distance down. And that will give you a matching point on the inverse function. Okay? So if you do that with 2 or 3, you'll see, okay, so I'm going to pick this point here. Marked it in yellow, go across till it meets the line y equals x, and go down the same amount, and it gives you something here. And then we'll do another one, we'll go across and down, and it gives you another point here. So what you're going to see then is that the inverse function looks something like this. Okay? It's like a mirror through the line y equals x. Okay, that's one way you can do it. Now, in this example, look, you see the practice examples that I've given you there. You need to draw the line y equals x. then pick a couple of points and just translate them across. Okay? So you see the one, I'll just really quickly talk about the one with the parabola in it, right? So we can see how that would work. And you can do the rest, the other ones by yourselves. So, for that one I have, and it says that this is f of x, and it asks me to draw the inverse of it. Well, I have to put in my line y equals x first. Okay, now you can see there, look, there's 1, 2, 3, 4, 5 points that are clearly labelled on the thing. So here's what you can do. So, pick a point in your parabola. So I'm going to pick this one up here. Well, say here. Now I'm going to go across horizontally till I meet the line y equals x. And then I'm going to go that same distance vertically down. So it will bring me down to about here. So look, I'm going to just do it with a big dot just so it's clear. Now I'm going to pick one here. Across till I meet the line and down. And that's going to give me another point there. Now look at the vertex of the parabola. Look, it's right on, so it's not travelling any distance, so that's going to stay where it is. Now I'm going to try one more, so I'm going to go from here across, same distance down, gives me a point. And if I go here and here, that gives me another point, right? So now this isn't the greatest example because it's just I'm not drawing it with graph paper, but you can see, look, it's just going to look like that. Alright, it'll be easier when you're doing it with graph paper that you can count off the distances easier, but that's roughly what it's going to be like. So task 3 is domain and range of inverse functions. Alright, so look at the first one that you've got there. So here's what's interesting about this. If you take a function, so we see we have minus 2 and we have 5, and it goes like this, and that's f of x. Now let's look at that. If I have the domain and the range. Now look, when you're determining domain and range from a graph, to determine the domain, you look at the x's. So where do the x values start? The x values start here at minus 2 and they end at 0. So it's minus 2 to 0, and both are included because of the full dot. What's the range? You're looking at the y value. So the y values start from here and go up to here. So it's from 0 to 5. 0 to 5. Now, here's the thing about this. If you are to reflect this across the line y equals x, well, here's what you're going to see. You're going to see something like this. So this is what you're going to get, this image here. That's your inverse function, right? Because I did it really quickly there. I just reflected it through the line y equals x. But if you look, what's actually happened, for the inverse function now, the domain is 0 to 5, and the range is minus 2 to 0. So what actually happens is the domain of a function is the same as the range of its inverse, and vice versa, right? Because if you think about it like this, let's look at it this way. And just to answer that question, so to use the image to write down the domain and range of both. Okay, so that's what we did. We reflected it and we wrote down the domain and range. But just think of it like this, right? What you have, let's say you have, this is domain and this is range, and the function is f of x. So it takes something from the domain and brings it into the range. But now, what does the inverse function do? The inverse function takes that and brings it right back to where it started. So that means that the range of the first function is the domain of the second, and vice versa. So that's the connection between domain and range. For inverse functions, the domain and ranges swap. That's what's key. So I'm going to let you practice the last couple in that task 3 before we look at task 4. Right, we're going to start with task 4 really quickly. Task 4, it gives you two functions, f of x
equals 2x minus 1. G of x equals a half x plus 4.
Now we have to use here the relationship between domains and ranges of functions and their inverses. So we know that the domain of f is the range of f inverse, and the range of f inverse is the domain of f.
So here's a way to think about this, right? If you're asked to find f inverse of 7, well, we don't know what f inverse is. We can find it.
We can find f inverse from f of x and plug 7 in, right? But there's another way to do it which might be quicker. That's thinking of it this way. F inverse and f, consider the two functions. We want to know what we get as an output if we put 7 as an input in f inverse of 7. That's the same question as putting 7 as an output of f. What input gives 7 as an output of f? See, we flip the domain and range. We flip the output. The output of one function is the input of the other, and vice versa.
So that means that 2x plus 1, that's f of x, equals 7. Which value of x, which input, gives me 7 as an output? If you solve that, x is 4. So f inverse of 7, we try that down here. So that means f inverse of 7 equals 4. That's because we know that f of 4 equals 7. Right? That's how inverses work. F takes 4 to 7, f inverse takes 7 back to 4. We use the same principle for g inverse of minus 2. G inverse of minus 2. So that's 2 as an input to G inverse is the same as 2 as an output to G. So what value gives 2 as an output in G? We take it from there. Okay.